We will now review naming acids. Acids are compounds that will produce the hydrogen ion in water. Of course, we don't find the hydrogen ion in water. It always bonds to 1, 2, or 3 water molecules. So we show it bonded to one water molecule, the hydronium ion. And this is the Arrhenius acids. It's the first of 3 definitions of acids. We will go into the second definition when we cover acids fully. So we have 2 types of acids that we will name in 3 naming types. We have binary acids, which is hydrogen with one other nonmetal, and this is in water. And we have ternary oxyacids, which is hydrogen with a polyatomic anion. We have 2 naming conventions on the anions, so we have 2 naming conventions on those ions, on those acids. The binary acids, hydrogen with one other nonmetal. The name is going to include hydro, the root of the nonmetal, and then it'll end up with the ic, followed by the word acid. So aqueous hydrogen chloride, when we dissolve hydrogen chloride in water, it becomes hydrochloric acid. So we have chlorine, so chloric acid, hydrochloric acid. Hydrogen with fluorine, when we dissolve that in water, hydrogen fluoride, when we dissolve hydrogen fluoride in water, the fluorine becomes the root here, so hydrofluoric acid. When we dissolve hydrogen bromide in water, it becomes hydrobromic acid. So hydro is only with the binary acids. Only when we have hydrogen with one other nonmetal do we use hydro in the name of the acid. Then we have the ternary oxyacids. Ternary means 3 elements. Oxy means oxygen is present. Acid means hydrogen is present. Well, that doesn't always work because we're throwing in the acetate ion, which is more than just 3 elements. Well, actually, it'll be 3 elements in that one. So this is hydrogen with a polyatomic anion. The polyatomic anion has 2 forms, 2 name conventions. It's either ate ion or ite ion. And as we remember, the ite ions have 1 less oxygen, like sulfite has 1 less oxygen than sulfate. So the ite ions have 1 less ion than the ate ions. But the ate ions, when we add enough hydrogen to turn it into acid, it becomes an ic acid. So we're taking the root of the ion and changing the ending to an ic ending and throwing the word after it. So acetate ion, C2H3O2 with -1 charge, we add 1 hydrogen to neutralize the charge and it becomes acetic acid. ClO4- perchlorate ion, we add 1 hydrogen to neutralize the charge and it becomes perchloric acid. Sulfate, SO4 with 2- charge. We'll add 2 hydrogens to neutralize the charge. And for sulfur and phosphorus, we're going to change the form slightly. We're going to expand the name. So instead of being sulfic acid, we expand it to sulfuric acid. For the phosphate ion, PO4 with the 3-, we're going to expand the name a little bit, so instead of being phosphic acid, it becomes phosphoric acid. And we have to add 3 hydrogens to neutralize the 3- charge. For the ite ions, the ions that end with the suffix of ite, they're going to form an acid that ends with the suffix of OUS, us. So hypochlorite ion, ClO with a -1 charge, we use 1 hydrogen to neutralize the charge, and it becomes HClO hypochlorous acid. The sulfite ion, SO3 2-, we need 2 hydrogens to neutralize the charge. It becomes H2SO3 sulfurous acid. Nitrite, NO2-, add 1 hydrogen to neutralize the charge and becomes nitrous acid. With the ternary oxyacids, we don't have to use the aqueous on them. We don't have another name that we would use. For the binary acids, as a pure compound, we name them using the covalent compound names. So hydrogen chloride, hydrogen bromide, and then they turn into acid only when dissolved in water. These compounds, we only give them acid names so we don't have to show the aqueous physical state.